I would say, this really is an iterative process. And it takes a long time. Managing so many doctoral students, they have very bright ideas. And then as a faculty, my job every day is I will try to shoot down the idea, saying, hey, this idea is not workable. You cannot work on this idea because you cannot solve the problem. You don't want to boil the whole ocean, right? We need to have the combination of several things. Number one, is this problem intellectually exciting? That is, in the plain English, is it interesting? Clearly, interestingness is very subjective, right? I find this interesting, I do not find that interesting. Someone like hiking, someone like swimming. It's a bit subjective, but still, there's a kind of a generally accepted sense in the academic community of what's interesting, right? If everyone said this is not interesting, then you have a problem. If someone said it's not interesting, but someone said it's interesting, then you have your audience. Make sense? So yeah, that's number one. That is how intellectually exciting it is. Number two is rigor. Because we're in the science community, so you don't want to just say, oh, this is interesting, like rumors on the internet, right? They are interesting, but they are not scientific. So to be scientific means it's true, right? And you can repeat that so that your discovery or your findings will be tested by others and it still holds. So to do that, then you really need to be very rigorous in your research process. Like you need to have the right data set, you need to have the right methods, right? And then all these kind of different considerations in the research design. And the third one is called impact. That is, will this research question create impact? And if there's a question that only you are interested in, but it doesn't have a meaningful impact, then probably don't want to work on it. Most of the problem is that it's too ambitious and just too ambiguous. So we feel, hey, this is too small. I don't want to work on that bigger problem. And turns out that big problem has so many moving parts that in the end you cannot see anything. You get it? So then you're wasting 2 or 3 years. In the end, you cannot see anything scientific. That's a terrible idea. Technology is evolving. We're getting a lot of sensors, a lot of big data. And with the AI examples I talked to you, we can analyze the data in a very efficient way. And then with lots of big data coming, really life will be much better. And there are so many potentials using IT.